and now we are going to discuss about the next topic in this second unit in wireless communication, that is frequency division multiple access technique. In this Fdma, we are assigning individual channels are assigned with the individual frequency for each user. Okay, see, already we have discussed that in that logical separation diagram. These channels are assigned on demand to the subscribers who request service. Guard bands are maintained between the adjacent signal spectra to minimize the crosstalk between the channels. Okay, here each user is allotted with a single frequency. In that frequency, for the entire time they are going to transmit or receive their data, and each user is separated by a guard band between them, okay, in order to avoid that crosstalk between the channels. During the period of call, no other user can share the same frequency band. In frequency division duplex system, the user are assigned a channel as a pair of frequency. One frequency is used for upward channel, and while the other frequency is used for the downward channel. When you are going for this frequency division multiple access, one phone circuit per channel. Here we are having a one separate circuit for each channel, and idle time causes that wasting of resources, but entire time the user can utilize the entire frequency. If they are not used the frequency for the entire time, it will be the waste of time. Simultaneously and continuously they are transmitting means they can transmit and receive the data simultaneously and continuously at any time. Okay, usually it is implemented in narrowband system. That example for this implementation of Fdma with FDD is in AMPS. In Fdma bandwidth of 30 kHz is implemented. Fdma compared to Tdma, fewer bits for synchronization. Here we are not in need of synchronization, concentrate on synchronization more. Fewer bits for framing, higher call site costing, that is call site cost also more, that is subscriber site cost also more. Fdma requires RF filtering to minimize the adjacent channel interference also. And another one problem we are having in Fdma, that is nonlinear effects in Fdma. When many channels are going to use the same antenna, and near the saturation region we are having this nonlinear effect. For maximum power efficiency, we have to operate that in channels in that near saturation region. When we are going for near saturation region, we are in need of the power amplifiers that are operated in the non-linear mode. So non-linearity causes the signal spreading. When signals are spreaded among that one, then we are having that interference problem. Intermodulation frequencies causes interference problem. In IM are undesired, that is intermodulation is undesired, and that causes harmonics. This harmonics causes interference with the other channels in the Fdma system. That decreases number of users and their performance. The interference outside the mobile radio band, that causes channel adjustment interference. RF filters are needed for reducing this channel interference that cause higher. Next we are going to discuss about number of channels in a Fdma system. Here this number of channels can be calculated as Bt minus Bguard divided by Bc, where Bt is the total number of spectrum allocated and Bguard is the guard band between each channel and Bc is the channel bandwidth. By taking these two, we can calculate the number of channels. Here is an example in advanced mobile phone system. We are using Fdma FDD and analog cellular system. Each cellular band is that is entire bandwidth is 12.5 megahertz, and the guard band is 10 kilohertz, and each channel is allocated with 30 kilohertz. If you are going for that one, number of channels can be calculated as 416 channels, that is 416 channels can be allocated with that 12.5 megahertz of simplex band. Then advantages of Fdma. The advantages of Fdma are that following. The complexity of Fdma system is lower when compared to Tdma and Cdma system. Though this is a changing as digital signal processing methods to improve the Tdma and Cdma. Fdma, it is technically simple to implement. It is simpler circuits, but here the capacity increases can be obtained by reducing the information bitrate and using efficient digital codes. Since Fdma is a continuous transmission scheme, Fewer bits are needed for overhead purpose as compared to the Tdma. Disadvantages of Fdma. The disadvantages of Fdma includes the following. Only modest capacity improvements could be expected from a given spectrum allocation. Fdma wastes bandwidth. If an Fdma channel is not in use, then it sits idle and cannot be used by other users to increase their capacity. So that is no share capacity. Fdma system have higher cell site system cost compared to Tdma because of the need of use costly band pass filters to eliminate spurious radiation at the base station. The Fdma mobile unit uses duplexes since both the transmitter and receiver operate at the same time. A duplexer adds weight, size and cost to a radio transmitter and can limit the minimum size of the subscriber unit. Fdma requires tight RF filtering to minimize adjacent channel interference. The maximum bitrate per channel is fixed and small, that inhibiting the flexibility in bitrate capability that may be requirement for 3G applications in future. Next, we are going for the time division multiple access. Here each user allotted with different time slots. They are having that buffer and burst method. It is a non-continuous transmission. As in Fdma, the data cannot be transmitted continuously. This is also digital data and digital modulation. Here the repeating frame structure will be like that one. One Tdma frame consists of a preamble and the information message, then the trail bits. Each information message is with different time slots for each user, and each slot consists of trail bits, synchronization bits and information data and the guard bit. Features of this Tdma: a single carrier frequency for several users can be allotted. Transmission is burst. Due to that transmission is burst, low battery consumption is enough for that one. Handoff process much simpler. FDD technique is used for duplexing. Switch instead of duplexer. Very high transmission rate. High synchronization overhead problem is there. Guard slots are necessary here. Number of channels in a Tdma system is given by n equal to m star b total into total minus 2 star b guard divided by bc. Here the number of channel can be obtained with the number of Tdma users per radio channel, and it multiplied with the total spectrum allocation minus 2 times of guard bands, because each user is separated by 2 guard bands, and bc is the channel bandwidth. Example of this Tdma is the GSM. Here we are using Tdma FDD technique. The forward link has a B total of 25 MHz and the radio channels of BC is 200 kHz. If M is 8 speech channel supported, and then if there is no guard band is used, means we can get that number of users per channel with this 25 MHz is 1000 simultaneous users can be utilized with this one. Okay, efficiency of Tdma. Percentage of transmitted data that contain information is called as efficiency. The frame efficiency eta f. Usually end user efficiency is less than that frame efficiency. Because of source and channel coding, we can get this eta efficiency by repeating the frame structure. That is, each user has separate slots. Each user is allocated with a separate slot, and for calculating that eta efficiency, we have to calculate first that number of overhead bits. Here the number of overhead bits can be given by BOH is NF into BR, NR into BR plus NT into BP plus NT into BG plus NR into BG, where NR is the number of reference burst per frame and BR is the reference bits per reference burst, and NT is the number of traffic burst per frame, and BP is the overhead bits per preamble in each slot, and BG is the guard equivalent bits in each guard bit time interval. So after calculating that BOH, we have to calculate that B total also. This B total is given by T frame duration TF into channel bitrate R. Then the efficiency can be calculated as eta F equal to 1 minus BOH divided by BT into 100, that is percentage of efficiency. So with that we have completed that frequency division multiple access and time division multiple access. We will discuss that code division multiple access in the next video. Thank you.